Hi everyone, my name is Cargo and Treasure. Welcome to my YouTube channel, and today we're going to discuss a wonderful topic called machine learning. I was able to learn this from a wonderful course called Diploma in Machine Learning at Allison Learn, recommended by my lecturer, Mr. Galiwango. A big thanks to him. So what's machine learning? Machine learning is a field of study that enables computers to learn without being explicitly programmed. Initially, tasks were solved using traditional programming, where computers were given rules to follow and step-by-step methods to follow. But as the tasks became more complex, we found that these rules were increasing exponentially. That's where machine learning came to solve that problem of scalability. With machine learning, computers are fed data and they're able to learn and solve complex tasks without rules being defined for them. So we have two types of machine learning. There's supervised machine learning, whereby the machines learn via the labeled data, human labeled data. There is some human work that is done in that process of learning in terms of labeling. While in unsupervised learning, no labels are required. The computer is just fed the data and is able to learn the patterns from that data and solve the tasks. So we have two types of models. We have deterministic models and probabilistic models. With deterministic models, we find that there is no room for randomness, whereby if you have a particular input, you get the same output every single time, for example, in mathematical equations. While in probabilistic models, we find that there is room for randomness or uncertainty, whereby if you have a particular input, you may get different outputs depending. So for example, we find it in weather forecast models. So supervised machine learning, with supervised machine learning, we find there are two categories. We have regression, whereby it's the type of model that deals with data that's continuous in nature, that's numerical data. For example, if you're predicting prices, anything numerical, that's regression. While in classification, we find that you're dealing with categorical data that is discrete in nature. For example, if you're differentiating between a boy and a girl, male, female, that's classification. And then we find in models like logistics, decision trees, as you can see. So there are steps that you take in order to build a machine learning model or in the machine learning pipeline in order to create a solution. First of all, you collect the data, perform exploratory data analysis, where you're able to gain the insights from the data. So what do you look out for in exploratory data analysis? Look out for the number of observations, the features, the data types of the features, the type of problem that you're trying to solve, and the outliers, and do you need to engineer any feature? That's what you look out in exploratory data analysis. After getting these insights, from these insights, you're able to prepare the data for machine learning algorithms. That is through the data cleaning of feature scaling, which I'll discuss soon. And then after preparing the data, you select a model according to the data, and then you train it. So when you train it, you get the performance of the model. In order to increase the performance, you go to step 5, where you have to fine-tune the model. And then with step 6, you present the solution to stakeholders, and step 7, when the solution is approved, you launch, monitor, and maintain your system. So what's feature scaling? Feature scaling, you're transforming numerical features so they can be on a similar scale. There's normalization, whereby you transform them so they can be on a scale of 0 to 1, but it's affected by outliers. While you have standardization, whereby you can have a center feature have a mean of 0, and you can have either positive or negative values. So in data cleaning, you look out for the duplicates, relevant data that may affect the training of the model, and mislabeled classes. How do you clean? You can either combine features, you can remove features if they are unnecessary, or you can add more features. And components of a machine learning model. What components are needed in order to create your model? First, you need a prediction model. That's an algorithm that can be used to predict outcomes from given inputs from the data. And then you need a cost function. A cost function is able to know how correct your prediction is. And then an optimizer is able to adjust the model in order to improve this cost function, improve the performance of the model according to the cost function. And then you look at also parametric models. Parametric models, parametric models, you know which model to fit the data. You assume you're able to make assumptions on the data. You can say the data is linear. Let me apply a linear regression. And then for parametric model, here the data decides. You do not make any assumptions on the data. So linear regression. Let's talk about linear regression as the first one. Linear regression, you assume a linear relationship. So here is the formula whereby you have y as a target, and then you have the x as the features and the theta as the weights that are assigned to those features. So here you consider a linear relationship. And then the cost function is the mean square, whereby you can subtract the predicted value from the true value, and then you square them, and then you get the sum of them, the average of them. And then after that, you can improve this model via the gradient descent optimizer, whereby you're able to adjust the learning rates, either increase it or decrease it according to the mean square error that you have received. Then you go to the logistic regression. Logistic regression is mainly used for classification problems. So we find that the prediction model is a sigmoid function. A sigmoid function has a minimum value of 0 and a maximum of 1. So you find that the output that you're going to get is going to be a range. It's going to be a probability between 0 and 1. So the cost function is the log loss. The log loss, the advantage of it is that it gives a heavy punishment for wrong predictions. And then the optimizer is a gradient descent, whereby you also increase or decrease the learning rate in order to decrease the log loss. So let's talk about the k-nearest neighbors. With the k-nearest neighbors, you have your test points, and then you calculate distance between the training data and the test points. So you can use Euclidean distance or Manhattan distance for calculating this distance, depending on how similar your data is. And then after finding the k-nearest neighbors by sorting out the pairwise distances, you're able to classify the point based on a majority vote. Then we go to decision trees. Decision trees, it's a simple algorithm that is easy to understand, whereby we choose a feature based on the information that you're going to gain from it. The entropy, how important that feature is, and then the Gini index, that is how pure the given split is. Yeah. And from there, after choosing the feature, you ask a question. For example, you can see this decision tree. You can look at the weather. You ask, is it sunny, cloudy, or rainy? And then you're able to split the data on the results of that question. Then you can repeat the process until you meet a condition whereby you can say the split is now pure, or you have reached maximum depth. You set the condition, and then remember, there you're able to make a prediction. So the decision tree can be fine-tuned, or that it can be improved by pruning, whereby you limit the depth of the tree in order to prevent overfitting. So decision trees, there are pros and cons. First of all, the decision tree is easy to explain and visualize, as I showed the decision trees in the previous slide. It can capture the nonlinear patterns. It is sensitive to noisy data, and the cons. It is sensitive to noisy data, and it's biased with imbalanced data sets. So you have to first balance the data sets before you put it into a decision tree. And then you have use cases such as classification and regression problems. That's one big advantage of it. It covers for both. So let's talk about ensemble learning. Ensemble learning is where you combine multiple models to make a better final prediction. There are two types. Bagging, you have a number of different models that you train parallelly with overlapping training sets. That's why you find the random forest, whereby you have a number of decision trees that you are training at the same time, and then the decision trees are able to vote on the results. That is random forest. And then boosting, you have a sequential tree that's growing with weighted samples, whereby the model is able to learn from a previous step, and the learning goes downwards. For example, the AdaBoost. What are the advantages of the random forest? first of all, it's robust to outliers. Remember, the decision tree alone was sensitive to noisy data, so it's robust to outliers. It lowers the risk of overfitting. The cons, it's biased when dealing with categorical values and has a slow training because now you're training more than one tree. Then let's talk about the support vector machine. The support vector machine is a machine learning model that tries to find a line that separates the classes with the largest possible margin. So it can be a hard margin whereby the classes have to be, whereby the classes have to fall in, the points have to fall in their right classes strictly, or a soft margin where you can have the room for error. So there are variations such as it's usually a binary classification algorithm, but you can have a multi-class support vector machine, where you can have a vector machine of one-to-many or one-to-one classes. You can combine many binary vector machines, and then you have the vector machines for regression. So let's look at unsupervised learning. We're going to look at two main algorithms, that's K-means and principal component analysis. Let's start with clustering. K-means falls under partition clustering. Yeah, and this is a model that is used to group similar data points. Yeah, and then we have use cases of clustering involve anomaly detection, customer segmentation. And if you were to look at the steps that you take while doing the K-means clustering, here you choose the centroids, or the K points, you assign data points to the closest centroid, and then you recompute the centroids, and then you repeat until there is a minimum decrease in squared error. That's how you work with the K-means clustering algorithms. So with the pros and cons, it's simple and easy to implement, but the cons are sensitive to outliers, sensitive to initial seeds. You need to choose the right centroid. Yeah, it's sensitive to the centroid that you choose, and it's also suitable for discovering the clusters that have irregular shapes. For example, if it has a hook shape. The principal component analysis, this is a unsupervised machine learning model that's used to reduce the number of dimensions. So you can use it also in the pre-processing stage, whereby you're trying to reduce the dimensionality of the data while keeping the information loss at minimum. Data that has a lot of dimensions can also affect the training of the algorithm, in the training of the machine learning in a negative way. So what are the cons? It can lead to information loss, performing lossy compressions, and it also assumes that the variables are linear correlated, which is not the case some of the times. What are the use cases? You find it in the image compression, and it's also a data preprocessing step. So the machine learning project idea that I'm going to take up is called grid sentry. So the idea is a prediction of transformer failures based on acoustic signals. So here you listen to the sound that is produced by the transformer, and from there able to differentiate what type of fault the transformer has. It enables predictive maintenance and early interventions in case of any problems that are with the transformers. Why do we need this? There are sudden failures. Sudden failures in transformers can lead to blackouts, fires, and can lead to also greater catastrophes, can even lead to death in case it's a huge failure. And you find that these failures are frequent in East Africa and frequent in Uganda, whereby we are always replacing the transformers, and which are also difficult to replace. So if we have an early intervention by machine learning, this is very needful. The data we're going to look at is acoustic partial discharge data sets, and we're going to look at the machine learning. It's going to be a supervised machine learning problem where we're trying to classify the different faults of a transformer based on the partial discharge, or the discharge of the transformer. And then we shall use the principal component analysis to reduce the dimensionality of the data in order to reduce on the computation power needed to train the model, and then shall use K-means in order to cluster the different audio signals. And as we continue training, we shall go to more advanced machine learning models such as the CNN, the convolutional neural networks and transformers. And Depending on the result, we may also end up in assembly learning where we can combine these models in order to get the best results. The potential market, I look at the power utilities, which is a vital infrastructure in our country, in Africa, and globally. Thank you so much. I remain Cargo and Treasure. If you enjoyed this, please leave a like, share, and comment.